Hi, Assalamualaikum warahmatullahi wabarakatuh. In the previous video, I have shown you how to solve this example, which is to find the standard deviation of the random variable x. And in that process, you have come across the following integral where you have to find the result of this one right here, and this is considered as some sort of a standard integral where the result is already known as the inverse tangent of x plus c. Okay, so that's the result, and as I have told you in the previous video, this is considered as a standard result, but to those of you who are unsure how the result comes about, well, this is the video explicitly for explaining the result given here. So in this video, that's what I'm going to do. I'm going to explain how the result of the integral here is as such. Okay, and in order to get this result, there are also two other standard results that you were supposed to remember or at least be familiar with. For example, this is the trigonometric identity. 1 plus tangent squared theta is equal to secant squared theta. So that's considered a pretty basic trigonometric identity that you all have to remember. But again, if you don't, it's okay. We can, work around it. It's just that it's going to take a longer time, okay? And also, if you differentiate tangent theta, the result is going to be equal to secant squared theta. So these are considered as like pretty standard results, and I'm going to explain how we can get those results using some sort of basic knowledge that you have already obtained when you were in school. Okay. All right, we're going to start on with solving the integral. So let's say we have this integral, okay, and we're going to let x equals to tangent theta. Okay, therefore what we have right now is we're just going to turn x into tangent theta. So we have 1 over 1 plus tangent squared theta. And notice that we have to change dx right here into something related to d theta, because right now in the expression we have theta instead of x. So that's what we need to do. We need to find out what's d theta to be put right next at this position. Okay, so in order to do that, we are going to use this expression or equation that we have. X is equal to tangent theta. Therefore, dx d theta is equal to differentiating tangent theta. And if you know the standard result, then you can come up with the answer straight away, which is equal to secant squared theta. But let's say you have no idea, and what we can do is we can use your prior knowledge, very basic prior knowledge, in order to get these results right here. And that's what I'm going to show you next. Alright, so here what we got is tangent theta, and we know that tangent theta is actually equal to sine theta over cosine theta. So I assume everybody is familiar with this. And when you want to get the derivative of a function in this manner, what you need to do is we can consider this to be equal to f, and this part here is g, and in order to get the derivative of this function, we can apply the formula where you have gf prime minus fg prime over g squared. So this is the formula that you can apply in order to find the derivative of this function right here. Okay, so that's what we're going to do. Now g is cosine of theta, and if you differentiate f, you will get cosine of theta as well, minus f is sine of theta, and if you differentiate this one, you will get negative sine of theta over cosine of theta cosine of theta squared, we can either write it in this form, or you can also write it in this form. Okay, so it's okay, which one that you choose is okay. Next, what we can do is we can turn this into cosine squared theta. This is plus sine squared theta, and this is cos theta, and you square it. And by applying another well-known trigonometric identity, this is equal to 1. So this is 1 cosine theta squared, okay, and this is equal to 1 cosine theta, you square it, okay, this is the same thing. And we know that 1 over cosine of theta is secant of theta. So this is secant of theta squared, or you can also write it in form secant squared theta. So that's the result here when you differentiate tangent theta, okay. So therefore dx d theta is equal to secant squared theta, and therefore dx is secant squared theta d theta, okay. Right, so that's what we're going to do. We're going to write down the result here, dx. So dx is equal to secant squared theta d theta. Okay, I'm just going to erase this part, okay, because we're done with showing the result of the derivative for tangent theta. Next, hang on. Okay, and then you can see that the result here for this bottom part here is going to be equal to secant squared theta as well, according to the trigonometric identity given here. And if let's say you can't remember this part, like for example you forget what's the result of 1 plus tangent squared theta, it's okay, because you can actually derive it quite simply. Okay, so for example, we know that 1 plus tangent squared theta is equal to 1 plus, so what is tangent? We go back to the very basic definition, which is sine theta over cos theta, and you square it, right? And that is equal to 1 plus sine squared theta. You can write it in this form, over cosine of theta, and you square it all, okay. So that's the same thing really. And we have learned that in order to do this process, we need to make sure that we have the common denominator at the bottom right here. So here we've got cosine squared theta. At this part here, we will have cosine squared theta plus sine squared theta, yeah. Then this is the we can use the common result of trigonometric identity really, and this is equal to 1. So we have 1 cosine squared theta, which can be written as 1 over cos theta, you square it, and we know that 1 over cos is actually secant, so secant theta squared, and this is also equal to secant squared theta. You can write it in this form, okay. So that's what happens next. So here we have integral of 1 over secant squared theta times with secant squared theta d theta, and that can be cancelled out. So we are left with integral of a constant, which is 1 d theta. And if you integrate a constant, you will get theta plus c in this case. And what is theta? Again, we go back to this part right here, this definition here. We have already said that tangent theta is equal to x. Therefore, if you want to find what's theta, theta is going to be equal to inverse tangent of x, and we can replace theta as inverse tangent of x plus c. Okay, so this is the result that you have seen right here, which has been used in solving this example. and I hope this video has been helpful to some of you in trying to get yourself around this integral. Okay, thank you very much for watching, and I'll see you in the next video.